Hey everyone, this is lesson 18, L'Hopital's rule, and we want to use L'Hopital's rule whenever we have what's called indeterminate form, which basically means when we see a limit that we compute and we see that we get 0 over 0, or maybe something like infinity over infinity, that's a good time to use this rule. And the rule basically says that we'll rewrite the limit by taking the derivative of the top and then taking the derivative of the bottom. Okay, so let's see some examples. Here we can see, you might recall this from lesson number 2, that this one here, this limit will equal to 1. Well, if I were to plug in 0, sine of 0 is of course 0. And when I plug in 0 here, we also get 0. Okay, good time to use L'Hopital's rule, right? So I'm going to derive, let me rewrite the limit here. And I'm going to derive the top here. The derivative of sine of x is in fact cosine of x, and the derivative of x is just 1. So now if I try to plug in 0, cosine of 0 should give us 1. Of course, we have 1 on the bottom, and this will just give us 1. Okay, so that's how this identity was 1 way back in lesson number 2. Okay, all right, let's look at this one here. This was another identity, and in lesson 2, we saw that this was equal to 0. Well, we know that when we plug in 0 into this limit, or into this function, we're going to get 0 over 0. So this is a good time for L'Hopital's rule. All right, I'm going to rewrite the limit. So limit as x approaches 0. I'm going to derive the top. So here I can see we have 1, the derivative of 1 is 0, minus, and then cosine. Well, when I derive cosine, I just get negative sine, but there's already a negative here. So this becomes sine of x over 1. And then now if I plug in 0, right, we get 0 over 1, which is, of course, 0. Okay, so that's how this happened way back in lesson 2. All right, let's look at a couple other examples. We can see here 1 minus sine of x over cosine of x. If I plug in pi over 2, think about where pi over 2 is on the unit circle. It's over here, and we know that the coordinate for that is 0 and 1, right? So if I plug in sine of pi over 2, I'm just going to get 1. So 1 minus 1 is 0. And then cosine of pi over 2, that's just going to be 0. Good time for L'Hopital's rule, right? So this is the limit as x approaches pi over 2, right? Now, if I derive this negative sine of x, I'm going to end up with negative cosine of x. And now down here, if I derive cosine of x, I'm going to end up with negative sine of x, right? This is going to cancel and become positive. And from here, we can plug in pi over 2. So remember, we went over already, cosine of pi over 2 is going to be 0, and sine of pi over 2 is 1. And this, of course, just gives us 0. Okay? All right, let's try with this one here. Number 4, I'm going to start by rewriting, well, assuming that I have to use L'Hopital's rule. Let's see, if I plug in 0, we end up with 7 times 0, which is 0. Well, what is cosine of 0? Let's see, cosine of 0, I'm going to just draw the point up there, and the coordinate for that would be 1, 0. So cosine of 0 should be 1, right? We end up with 1 minus 1 up there, so that's 0 over 0. Okay, we are using L'Hopital's rule. So let's see. What happens when I derive this in here? So cosine of 7x minus 1. Well, we know that minus 1, that derivative there is 0, but cosine of 7x, that's a chain rule. So derivative of the outside is negative sine, copying the inside, and then times the derivative of the inside, which is just 7. So I'm going to put that 7 here in the front. Let me put that negative again. There it is. Now the derivative of x squared, right? We want to derive the bottom, 2x. Okay. All right, let's try to plug in 0. What happens now? Let's see. If I plug in 0, I'm going to get negative 7 times sine of 7 times 0 is 0 over 2 times 0 is 0. Okay, so what do we get? What's sine of 0? Isn't that just 0 according to my point here? So I end up with another 0 over 0. Uh-oh. I got to just use L'Hopital's rule again. Okay, so let's do this one more time. We do it right because we do it twice. So, well, the derivative of the bottom is just 2. And what's the derivative of the top? Let's see, negative 7 is a constant. All right, derivative, I'm going to derive this sine of 7x. So the derivative of the outside, that's cosine, copying the inside. And now times the derivative of the inside, which is another 7. So 7 times 7 up there in the front. Okay, isn't that just negative 49 times, what happens if I plug in 0? Let's see, cosine of 7 times 0 is just going to be cosine of 0 over 2. Well, cosine of 0, that's just 1 according to my point up here. So that's negative 49 times 1, meaning negative 49 over 2. There we go, we finally got our answer. Okay, so you can see here how L'Hopital's rule works. And that's basically the idea. All right. Remember that if you get infinity over infinity, you can also use L'Hopital's rule. Okay.